Hey everyone, and welcome. Today, we are going to pull back the curtain on the factory of the future. We're talking about how AI, data, and a totally new way of thinking are completely flipping manufacturing on its head. Let's jump right in. So, let's kick things off with a pretty wild question. What if a factory wasn't just a building full of machines, but was, well, a living system? Something that could actually think for itself, adapt to changes on the fly, and even see problems coming long before they happen. You know, it sounds like something out of a sci-fi movie, but this is the real idea at the core of the smart factory. All right, here's how we're going to break it all down. First, we'll look at why we're moving past the old school assembly line. Then, we'll dive into the blueprint of a smart factory. After that, we'll follow the data to see how it all connects, understand how the factory actually thinks, and finally, and this is the big one, we'll see exactly where we, the humans, fit into this amazing new picture. Okay, first things first. We have to get our heads around the fact that we are living through a massive shift. I mean, a fundamental one. This is all about leaving behind that rigid, unchanging model of production that's basically defined manufacturing for the last 100 years. You see, the end game here isn't just about cranking things out faster. It's about building a production system that is just incredibly responsive. I want you to picture a factory that can react in a split second to a sudden spike in customer orders, or a hiccup in the supply chain, or even a single machine that's about to break down. That's the real power of adaptive production. So how in the world does this all work? Well, to really understand the smart factory, we've got to get on the same page with a few core concepts that make up its foundation. First up is the big picture idea: smart manufacturing. The best way to think about this is as the overall philosophy. It's the how, right? It's the whole strategy of weaving together digital models, automated controls, and actual intelligence to create that super adaptive system we were just talking about. Now, here's where it gets really interesting, and the distinction matters. Smart manufacturing is the concept. It's the how and the why. A smart factory, on the other hand, is the place. It's the where. It's the physical building with all the sensors and robots and networks that bring that big idea to life. It's a subtle difference in words, but it's absolutely crucial for seeing the whole picture. And sitting right at the heart of all of this is an incredible piece of tech: the digital twin. Honestly, the easiest way to wrap your head around it is to imagine a perfect one-to-one virtual copy of a real machine, or heck, even an entire production line. This virtual replica gets fed a constant stream of real-time data, which lets you monitor, simulate, and predict what's going to happen in the real world, all without any of the real-world risk. It's a game changer. So, if that digital twin is the factory's virtual body, then data is its lifeblood. Let's take a look at the factory's nervous system, how it actually senses what's going on and communicates that information in real time. This gives you the whole journey. It all starts right down on the factory floor, with sensors gathering tons of data. That data then zips through the network to get processed, sometimes right there on the edge for lightning-fast decisions, or up in the cloud for deeper analysis. And finally, it connects up to the high-level business systems, like ERP for planning or MES for managing the factory floor. It's this constant, multi-layered conversation happening every single second. But of course, there's a catch. Keeping that digital twin perfectly, flawlessly up to date every single millisecond, that takes a massive amount of computing power, and it gets expensive. So the real trick is finding the right balance. A lot of systems now use what's called a hybrid fidelity twin. You have a super detailed, lightning-fast twin for local control right at the machine, and maybe a slightly less detailed one in the cloud for that big picture analysis. It's all about getting the right info at the right time without breaking the computational bank. Okay, so we've got the model and we've got the data flowing. Now, let's get to the brain. How does the factory actually make decisions? Well, the secret lies in two very different but totally complementary control loops that work in perfect harmony. The first loop is the PLC, which stands for Programmable Logic Controller. You should think of this as the factory's deep instinctual reflex. It's blazingly fast, it's deterministic, meaning it does the same thing every time, and its number one non-negotiable job is safety. It handles all those critical, must-not-fail operations to make sure the machines never, ever operate outside of their safe limits. And then you have the second loop, the AI adaptive loop. Now, this is the factory's higher-level thinking brain. It takes in all that rich data we talked about to learn, to predict, and to suggest ways to optimize everything. It isn't controlling the machine from moment to moment. Instead, it's providing advisory control, always looking for ways to improve efficiency and quality over the long haul. This slide just lays it out so perfectly. It's a partnership. You've got the PLC acting as that fast, safe reflex, and the AI as the slower, thoughtful brain. So the AI might suggest an adjustment to improve performance, but the PLC is always there, acting as the ultimate safety guard, making sure that suggestion never, ever violates a critical safety rule. This dual-loop design is exactly what makes it possible to add these smarts to older brownfield factories without having to start from scratch. But here's the thing. For any of this to actually work, the human operators have got to trust the AI's advice. That means transparency is everything. By using what's called explainable AI to show why the system is making a recommendation, by providing immersive VR training in a safe space, and by designing crystal clear dashboards, we build that absolutely critical trust between human and machine. And that brings us to our final, and honestly, probably the most important part of this whole story. With all this incredible automation and intelligence, what happens to the people? Well, the answer might actually surprise you. This isn't about replacing humans, it's about empowering them. I just love this line from the source material because it nails it. The goal is to create intelligence that augments worker expertise. It's about building incredible tools that help people do their jobs better, safer, and far more effectively than ever before. This whole philosophy actually has a name, Industry 5.0, and it represents this huge evolution in our thinking, a conscious choice to put human needs and human expertise right back at the center of this whole technological revolution. The point is that technology should serve people, right? Not the other way around. And when you do that, the payoff is huge. We're talking about humans and robots working together as a team on really complex tasks. We're talking about AI systems that act like expert advisors to the people on the floor. Tools that let workers redesign a production line without having to write a single line of code. All of this creates workplaces that are safer, way more flexible, and frankly, a lot more interesting to work in. So as we wrap all this up, the real takeaway is this. The factory of the future isn't about taking people out of the equation. It's about completely redesigning the equation itself. The ultimate goal isn't just to build a smarter factory. It's to build a smarter, more collaborative partnership between humans and machines, which leaves us with the most exciting question of all, one that we're all a part of answering. How will we design it?